Namaste children, welcome back to 9th English lesson. Last class we learned unit 6 sprouts from 0 to infinity. We finished half of the lesson. Today shall we continue the lesson? Before that we can go through what we have learned last class. When the arithmetic class was in progress, the teacher was solving question on division. He drew 3 bananas on the blackboard and asked the students if they have 3 bananas and 3 boys, how many each will get. A smart boy in the front row replied that each one would get 1. He then proceeded to ask if 1,000 bananas are distributed among 1,000 boys, would each one get 1 bananas? A boy sitting in one corner raised his hand and stood up. The teacher stopped his explanation and waited for the boy to speak. He asked the teacher, if no banana is distributed among no one, will everyone still get 1 banana? There was a roar of laughter in the class. The teacher asked the students to stop laughing and explain to the boys what he was asking. It was, if 0 banana is divided among 0, would each one get 1? The answer would be no. Mathematically, each would get an infinite number of bananas. The boy had asked a question that had taken mathematicians to several centuries to solve. That boy was none other than Srinivasa Ramanuja. Where he was born, can you say, children? Ramanuja was born in Erode in Tamil Nadu on December 22nd, 1887. What was his father? His father was a petty clerk in a cloth shop. What about his childhood? He was bright in mathematics and he secured a first class in mathematics in the matriculation examination and he was awarded the Subramanian Scholarship, but he failed twice in his first year arts examination in college. So his father was angry. Till then we learn. Remaining portion shall we go? See, Ramanujan began to look for a job. Why Ramanujan began to look for a job? Because he was failed in history, English and physiology. So this disappointed his father. Ramanujan began to look for a job. He had to find money not only for the food but for purpose as well to do his calculation. He wants to eat food not only for food but also he wants some papers to solve his calculation, do the mathematics. He needed about 2,000 sheets of paper every month. See, how many of you have finished your maths notebook? Did all of you finish your maths notebook? Daily you have to practice some sums. Here, our Ramanujan need 2,000 sheets of paper every month because he is doing a lot of calculations. Ramanujan started using even scraps of paper he found flying on the streets. In the absence of the paper, he used scrap paper on the streets. Sometimes he used a red pen to write over what was written in blue ink on the piece of paper he had picked up. There is no paper, so he rewritten. In the paper, he wrote in blue ink. Again, he overwrote in that paper with red ink. Unkempt and uncouth, he could visit offices, showing everyone his frayed notebooks and telling them that he knew mathematics and could do a clerical job. Then he started search for a job. Uncouth. What is meant by uncouth? Can you say? Behaving in an unpleasant way. Unkempt. Not neat or cared for. തിരുത്തപ്പെടാതെ. He searched, unkempt and uncouth. He could visit offices. He showed his mathematical skills, mathematical calculations, and visited some offices to get a clerical job. But no one could understand what was written in the notebooks. But unfortunately, nobody understood what he has written in the notebooks, and his applications for jobs were turned down, and so his applications were rejected. He didn't get any job. Luckily for him, he at last found someone who was impressed by his notebooks. Finally, he got someone who was interested in his mathematics. He was the director of Madras Port Trust. Francis Spring, and he gave Ramanujam a clerical job on monthly salary of rupees 25. See, the day rupees 25, he started his job, clerical job. Later, some teachers and educationists interested in mathematics initiated a move to provide Ramanujan with a research fellowship. Some mathematicians and mathematical teachers tried him to get a fellowship, like scholarship. He will get some money from that fellowship. On May 1st, 1913, the University of Madras granted him a fellowship of rupees 75 a month. Luckily, he got that fellowship from which university? University of Madras. University of Madras granted him a fellowship of rupees. How much money he got? Rupees 75 a month. Though he had no qualifying degree. He has no degree. He was not qualified. Okay, children. Next paragraph. A few months earlier, Ramanujan had sent a letter to the great mathematician G.H. Hardy of Cambridge University. Few months earlier, Ramanujan had sent a letter to G.H. Hardy. He was a great mathematician of Cambridge University, in which he set out 120 theorems and formula. He sent 120 theorems and formula. Among them was what is known as Ramanujam series, a topic in definite integral of calculus. Among them was what is known as Riemann series, a topic in the definite integral of calculus. But Ramanujan was ignorant of the work of the German mathematician. Among them, he sent 120 theorems and formulas. In that, there was Riemann series, a topic in the definite integral of calculus. Integral and calculus is the different topics in mathematics. It is there, but unfortunately, our Ramanujan didn't know about that. Already it was written by Riemann. But Ramanujan was ignorant of the work of German mathematician George F. Riemann, who had earlier arrived at the series. It was a rare achievement. See, already Riemann achieved that, but our Ramanujan didn't, because he has no formal education, no qualifying degree, so he didn't came to know about that. Also included was Ramanujan's conjecture about a kind of equations called modular Peiri-Deligne. Subsequently proved this conjecture to be correct. And among these 120 theorems, there was included Ramanujan's conjecture about a kind of equation called modular equation. Among that, Ramanujan sent this conjecture. Conjecture means an opinion or conclusion formed on the basis of incomplete information. If we want to solve the problem in mathematics, we want to give proof. But here, conclusion on the basis of incomplete information. That is modular Peiri-Deligne subsequently proved this conjecture to be correct. Already Ramanujan wrote that, and afterwards Very diligent, proved it was correct. It did not take long for Hardy and his colleague J. Littlewood to realize that they had discovered a rare mathematical genius. So, Ramanujan wrote a letter to G.H. Hardy. G.H. Hardy with his colleague J. Littlewood came to understand this Ramanujan was really a genius in mathematics. They made arrangements for Ramanujan's passage and stay in Cambridge. So, Cambridge University, they invited Ramanujan to come to Cambridge University. They made some arrangements for that. On March 17, 1914, he sailed for Britain. So, on March 17, 1914, Ramanujan sailed for Britain. Ramanujan found himself a stranger at Cambridge because he was here only. He didn't go to college and he didn't get formal education. So, Ramanujan found himself a stranger at Cambridge. The cold was hard to bear. It was very hard to bear the cold there because it is cold country, and being a vegetarian, he had to cook his own food. Besides being, he was a vegetarian. So, Western countries, they are eating meat mostly. So, he didn't get proper food. Ramanujan himself wanted to cook. However, he continued his research in mathematics with determination. But with perseverance, he continued his research in mathematics. In the company of Hardy and Littlewood, he could forget much of the hardships. Hardships means difficulties he had to endure. His friends G.H. Hardy and Littlewood helped him. In Ramanujan, Hardy found an unsympathetic mathematician similar to one who knows the Pythagoras theorem but does not know what was the congruent triangle means. See, Ramanujan already know Pythagoras theorem, but he doesn't know a congruent triangle. Several discrepancies. What is meant by discrepancy? An illogical or surprising lack of compatibility or similarity between two or more facts. In his research, he could be attributed to his lack of formal education. So, he was doing research in mathematics, but he was lagging because of the lack of formal education. Ramanujan played with numbers as a child would with a toy. How a child is playing with its toy. Likewise, Ramanujan played with numbers. It was sheer genius that led him to mathematical truth. The task of proving them so important in science, he left for lesser mortals. Whatever the truth he find out, he want to prove that. Ramanujan was elected Fellow of the Royal Society in February 28, 1918. Already he got, we discussed, he got a fellowship in University of Madras and he got ₹75 per month. Here, Ramanujan was elected as the Fellow of the Royal Society on February 28, 1918. He was the youngest Indian to receive the distinguished fellowship. He was the youngest Indian who received this fellowship, the Royal Society Fellowship. He was the youngest genius. In October that year, he became the first Indian to be elected Fellow of Trinity College, Cambridge. Not only Royal Society, again Trinity College also elected him as the Fellow. His achievements at Cambridge include the Hardy, Ramanujan, Littlewood circle method in number theory, and all the three, Hardy, G.H. Hardy, J. Littlewood and Srinivasa Ramanujan, they made a circle in number theory that is called Hardy, Ramanujan, Littlewood circle method in number theory. Roger Ramanujan's identities in partition of integers, a long list of the highest composite numbers. Besides, work on the number theory and algebra of inequalities. In algebra, his work on continued fraction is considered to be the equal in importance to that of great mathematicians like Leonardo Euler and Jacobi. See, No, lack of formal education is difficulty for him to research, but this G.H. Hardy and Littlewood helped him more and more, so he proved himself in algebra. His work on continued fraction is considered to be equal in the importance of great mathematician. This Leonardo Euler and Jacobi, you know, they are the great mathematician. But in algebra, his work on continued fraction, it is equal to these great mathematicians. While Ramanujan continued his research for tuberculosis, then an incurable disease was devouring him. Now tuberculosis is not an incurable disease. It has proper medicine. If we find out early, we can cure that. But in that time, in 1914 and 1950, that time it was an incurable disease. While Ramanujan continued his research for tuberculosis, then an incurable disease was devouring. It is devouring. It is eating him. Ramanujan was sent back to India. His health condition was very bad. So he was sent back to India because of the severe cold, and he has to cook himself. He was a vegetarian, and when he disembarked, his friends found him pale. His friends found him very pale. Disembark means to leave ship, aircraft, etc. When Ramanujan came back, his friends found him pale, exhausted. He was very tired and emaciated, very thin and weak. He was very thin, weak, pale, very tired. To get the agonizing pain, he continued to play with numbers even on his deathbed. To forget the agonizing pain, causing extreme physical pain, that agonizing pain, because of the tuberculosis, his body was full of severe pain. To forget that pain, to escape from that pain, and the vali theriyama irukkiradhukku, what he did, he continued to play with numbers even on his deathbed. Even in his deathbed also, he is continuing play with numbers. Besides being a mathematician, Ramanujan was an astrologer of repute and good speaker. Not only mathematician, he was an astrologer, as well as he was a good speaker. He used to give lectures on subjects like God, zero and infinity. He used to speak on the topic God, zero and infinity. So Srinivasa Ramanujan was a great mathematician. Okay, children, you have to revise. I will send the note. You should write in your classwork and learn well. Thank you, children.